Hello and welcome to Zetron's Tech Talk, Part 2, answering 6 more important questions about integrating mission-critical push-to-talk with emergency communication centers. My name is Randy Richmond, and I'm Zetron's Standards and Regulatory Specialist and one of Zetron's mission-critical push-to-talk subject matter experts. This Part 2 is a continuation of Tech Talk Part 1, answering 6 other important questions about integrating mission-critical push-to-talk with ECCs. In case it's been a while since you visited, here are questions that were answered in Part 1. What can mission-critical push-to-talk do compared to land mobile radio? What is MCPTT group management and why is it useful? Can I upgrade my existing LMR console to do mission-critical push-to-talk? Can an MCPTT console also do LMR to MCPTT integration? Is there an advantage to integrating my GIS and CAD systems? And what about the mission-critical push-to-talk vendor's dedicated mission-critical push-to-talk console? Now for Part 2. Before we dive into our next set of answers, a note about mission-critical push-to-talk. FirstNet may be first to market with mission-critical push-to-talk. They call it FirstNet push-to-talk. But FirstNet is not your only option. All major carriers have declared their intent to support this global mission-critical push-to-talk standard. The answers I provide here are applicable for connecting to any carrier that supports these global standards. So let's jump right in. Question 1. Which mission-critical push-to-talk interfaces can I use to integrate my ECC? One option is to connect using a system called the Interworking Function, or IWF, defined by the third generation partnership project, otherwise known as 3GPP. When this is eventually available, it will support P25 LMR interfaces, including the CSSI and DFSI. A dispatch console system can connect to the IWF either via the LMR system, which has its own connection to the IWF, or directly to the IWF. And these interfaces support mission-critical push-to-talk LMR-like voice features, but not all of the mission-critical push-to-talk features. For example, those that we discussed in Part 1. This interface can also allow a dispatch console to communicate with MCPTT users who are on talk groups shared with your LMR system, but it can't provide CAD or video console integration. Another option allows you to connect using the same interface used by 3GPP compliant mission-critical services field applications, generically known as user equipment or UE equipment, or client interfaces. And these interfaces should be available from all carriers, can eventually support most, if not all, of the advanced MCPTT features, and is likely to be affordable. These interfaces will allow ECC systems to communicate with all of the agency's mission-critical push-to-talk users, not just those who are linked to LMR, and it can allow CAD and future video console integration. Both of these options are considered open standard in that the interfaces are defined and openly published by standards organizations and equitably available to all ecosystem vendors. Other options may exist that are deeply embedded in the LTE network, but these are not available to all ECC vendors and are either partially or completely proprietary, locking you into a single vendor and, due to lack of competition, likely to be much more expensive than the open standard interfaces for the long haul. The interfaces available to you will depend on your mission-critical push-to-talk carrier and your ECC solution provider, but one or both of these open standard options will probably be available from most sources. Question 2. What about IP backhaul to my carrier? It's important to realize that unless your agency has its own private LTE system, which is very rare, your connection to MCPTT will be to one of a handful of carrier data centers around the nation. Mission-critical push-to-talk is really a cloud service. The IP backhaul to your carrier's data center has to be capable of handling the types of and numbers of media sessions that your ECC will need. The number of sessions you need to support will be determined by the number of dispatch positions within your center and the number of talk groups or channels that you need to monitor. If you've used IP connections for connecting your dispatch console to your LMR system, for example using the Project 25 CSSI, you'll need much more bandwidth for mission-critical push-to-talk. Your options for IP backhaul to your carrier may be dictated by the number of sessions that your center needs. Using a wireless LTE connection might be possible for small centers with relatively low traffic. Otherwise, the significant bandwidth needed by the medium or large size ECCs can easily overwhelm the bandwidth of LTE sites that are covering your center. Medium or large size centers will certainly need wired connections, which may include MPLS with VPNs. In any case, since this backhaul is so important, you'll want to have a service level agreement with your backhaul provider, and your carrier is probably best positioned to give you advice on this. Finally, since availability and reliability will be very important, you will probably want to plan on redundant backhauls, and you may even want to consider using separate vendors for the redundant backhauls. Question 3, are there solutions if I need to connect to multiple carriers? If your communications center serves multiple agencies, you might be in a situation where one agency has selected one carrier and another agency has selected another carrier. Even if your ECC handles just one agency, that agency's jurisdiction might not be entirely covered by any single carrier, which may lead them to subscribe to 2 or more carriers. And here's where you're likely to need to connect to multiple carriers. Yes, it should be possible for any properly designed dispatch console system to simultaneously connect to multiple MCPTT carriers. This scenario is most easily achieved if all of the connected carriers adhere to the MCPTT standards. Be aware that there are some emerging console solutions that are designed to only support one particular MCPTT solution using that solution's proprietary interface. Such solutions are unlikely to work across carriers unless all of those carriers have to be using the same mission-critical push-to-talk vendor. It is widely known that FirstNet has no near-term plans to allow its FirstNet push-to-talk solution to interoperate with other carriers. An MCPTT console connected to FirstNet and other carriers can be used to patch traffic between those carriers in mutual aid scenarios. Question 4. What are the costs for integration? If you're hoping for dollar figures here, I'm sorry to disappoint you. It's just too early in the life of mission-critical push-to-talk to be able to answer that question. But I can answer the question of the likely types of costs that you'll encounter. And these costs will likely include upgrades to your voice dispatch console system for new interfaces, for new user interface controls to support new MCPTT features, and new high-definition wideband vocoders. You'll probably need to upgrade your archival logging recorder system for new interfaces, new vocoders, and new types of metadata, including talker ID, imminent peril, and presence. You'll potentially need to upgrade your graphical information system if you plan to use it to show the location of mission-critical push-to-talk field users. And you'll potentially need to upgrade your computer-aided dispatch system if you plan to use it for mission-critical push-to-talk dynamic talk group management. For example, creating a temporary incident-specific talk group and putting assigned field units into that group. Or if you plan to use mission-critical data for group or group mobile CAD applications. In many cases, an upgraded dispatch console system can broker information between the mission-critical push-to-talk carriers and the GIS or CAD system without the need for those systems to have their own independent connection to the carrier. You'll also need to consider the cost of the interfaces and connections between your ECC systems and your carriers. There'll be interfaces on your ECC system, at least one per dispatch position. There'll be interfaces and ongoing service with your carriers, and then there'll be IP backhaul between the two, perhaps redundant backhaul. And this is likely to include one-time fee for setup and perhaps new equipment, followed by recurring fees for service and maintenance. How can you fund these costs? Well, I wish I had answers to that very important question, but clearly FirstNet does not plan to fund these upgrades, and it's unlikely that other carriers will either. Potentially LMR upgrade or maintenance funds could be used and redirected to mission-critical services, but no agency is planning to suspend their LMR system before they connect to mission-critical services. So there has to be a period of time, perhaps several years, during which both LMR and mission-critical services need to be sustained. One helpful aspect to this is that LMR is largely funded by capital expense, whereas mission-critical services is largely funded by operating expense. And this might allow for both to exist for a short period of time. Perhaps federal grants or legislation might provide some eventual relief. Question 5. When can I start integrating mission critical push-to-talk with my ECC? If you're hoping for a firm date here, again, I'm going to disappoint you. Like the question of cost, it's just too early to tell. But I can provide some pros and cons of being an early adopter. And here are some potential hazards for adopting mission-critical push-to-talk too soon. Today's deployments by carriers are being done with one or two selected vendors, with their solutions required at the device level. Adopting now will severely limit your choices. Today's deployments are providing only core capabilities, and some of those may not yet be compliant to the 3GPP standards. Adopting now may require using proprietary solutions which could lock you in the long haul. Carriers don't yet have a clear process for testing and certifying mission-critical push-to-talk solutions, let alone communication centers that use solutions like mission-critical push-to-talk. There can be little assurance as to the level of 3GPP compliance for solutions. The actual end-to-end performance of the solutions has yet to be completely analyzed, and early deployments are not yet past their teething pains. Lots of lessons are still to be learned about being able to meet the target use cases. With all these hazards, there is an advantage to being an early adopter. It gives you a head start on figuring out the use cases of the mission-critical push-to-talk features and creating standard operating procedures for those. Such learning can be hastened by gradually but increasingly making use of mission-critical push-to-talk during planned events. My personal recommendation on this is that unless your ECC has a history of being cutting edge and is well-funded, most ECCs will be better off waiting for another year or two for the dust to settle. Costs and timelines and choices will be much more evident as time passes. Question 6. Where can I learn more about MCPTT integration issues? One of the best sources of information regarding integrating mission-critical push-to-talk with land mobile radio and with communication centers are from a series of reports from the National Public Safety Telecommunications Council, otherwise known as NIPSTIC. The LMR LTE interoperability report from 2018, although it has a focus on LMR, that it does include dispatch centers because of the nature of integration. There was also a requirements, broadband console requirements document from 2014 and a brand new document from July called the Mission Critical Push-to-Talk Console Report. And those are good reading. From an international perspective, the Critical Communications Association, or TCCA, out of Europe, is working on a control room implementer's guide, which ought to be published next year. And the Association of Public Safety Communications Officials, APCO, has a report with more of an NG911 focus. It's called Project 43 Broadband Implications for the PSAP. And this deals with all aspects, including operations, staffing, training, and cybersecurity. The Zetron was a contributor to all of these reports. And now for a bonus 7th question. What about NG911 and mission-critical push-to-talk integration? This diagram shows the major external connections between the ECC and citizens and between the citizen or the ECC and first responders, as well as the internal cross-system connections. The real value of integrating mission-critical services, or MCX, is not so that you can migrate your existing voice communications from narrowband to broadband. It's in the ability to support additional media like images and videos and data in support of situation awareness. The ability to handle additional media is much more enhanced when you, as an ECC, are able to share media received from citizens via NG911 and with first responders via MCX. On the other hand, if rich data comes into the communications center and has no outlet, the center's staff are left with information overload. Here are some operational examples of some of the things that NG911 and Mission Critical's integration might be capable of. As a 911 call results in an incident, just as it works today, CAD recommends the field unit to assign to that incident. With end-to-end broadband integration, CAD can create a custom Mission Critical Services group for that incident and send the caller's location and any associated media directly to the group. Or when an EMS unit is dispatched, end-to-end broadband integration could allow the EMS unit to listen to the ongoing dispatcher-caller dialogue, and while en route, this allows them to better prepare for treating a patient once they arrive. And as a technical benefit of having both NG911 and FirstNet, it may be possible for the NG911 EZNet and FirstNet to be able to back each other up for backhaul. And as you can see from this diagram, there are many systems within the ECC between the end-to-end citizen and first responder flow. In order to realize the potential for end-to-end broadband within your center, you'll first need to integrate the various ECC systems with each other. The ECC is Public Safety Communications Hub. It's the center of your communications. The automation expectation of broadband such as NG911 and mission critical services is all the more important in today's broadband world so as to ease the information overload of center staff. This is why it's important to select vendors who have a commitment to open standards and interoperability. And Zetron offers solutions for the entire ECC ecosystem and is committed to this pursuit. Hopefully you found these answers helpful. This slide shows a number of other resources available from Zetron that can help you get educated on the issue of ECC integration with mission critical services. If by chance you've not yet viewed part 1 of this Tech Talk, please also watch that video. And also visit the About and Resources page of our website for the following white papers and ebook articles. There's the Broadband Emergency Communications Center Solutions white paper, the article How Will ECCs Interwork with FirstNet, and the article Dispatch and LTE Push-to-Talk Integration. Thank you for viewing this Tech Talk. For more information on how Zetron can help you support public safety broadband within your ECC, please take advantage of the live chat feature of our website. Look for our sales and support page, send us an email, or give us a call. And if you visit our website, subscribe to our ZWire blog to keep abreast of today's issues impacting ECCs. Thank you.